Alright, welcome to the last video on rational functions. This is going to be the video where we put it all together and we look at some graphs. Now, in this class, we're not expecting you to be able to completely recreate the graph on your own, but the idea here is that you should be able to use these key features plus your graphing calculator to put together a good graph. If you try to use your graphing calculator alone, for some of these graphs it works okay, but some of them they're terrible. There's just not enough resolution in the graphing calculator to really see what's going on. So you need to put together what you know about rational functions with what you see in the calculator to get a good picture. Okay, so let's see what we're talking about. Let's start with the function r of x is equal to x plus 2 over x squared minus 4. Okay, and we want to get to a graph of this. Again, you don't have to graph entirely on your own, but you should be able to get these key features. So the four things that we should be able to find now, after seeing the other videos, we should be able to find the domain, the vertical asymptotes, the holes, and the horizontal asymptotes. Okay, so let's go ahead, and this is if they exist, because not all these things are going to exist every time. In the HA. Okay, so let's go ahead and write those down. So remember, for the domain, we're looking for zeros in the denominator. So our domain is going to be everything except for zeros in the denominator. Remember, to see the zeros, we really want to factor. The top is already factored. The bottom is the difference of two squares. So it's going to factor as x plus 2, x minus 2. So we can see our zeros in the denominator are going to be negative 2 and positive 2. So x is everything except for negative 2 and positive 2. Alright, so that's the same as what we looked at before with domain. Now, remember, everything that is excluded from the domain means the graph does not exist there. You have to decide if it's going to be a vertical asymptote or a hole. So over here's our reminder. Vertical asymptote are the zeros in the denominator that don't match the numerator, and the holes are the zeros in the denominator that do match the numerator. So let's go back to our zeros in the denominator. X plus 2 gives us the 0, negative 2. Let's put that down below so remember which is which, because we've got negative 2 and positive 2. Okay, so x plus 2 is the factor that it comes from. Does it have a factor that matches in the numerator? Yes, it does. So that factor matches, so that 0 is going to give us a hole. So we have a hole at negative 2. Okay, the factor matches, so that 0 is going to give us a hole at negative 2. Alright, now the factor at x minus 2, does that have a match? No, it does not. Remember, they have to match exactly. Same sign, same number, everything. So x minus 2 does not have a match. So its 0, positive 2, is going to be a vertical asymptote. Okay, so we've got a vertical asymptote at 2, a hole at negative 2. Now let's move on to horizontal asymptote. Remember, for a horizontal asymptote, we're going to look at the degree. If the degree is less on top, it's 0. If they're the same, we're going to look at the leading coefficients. And if it's more, there's no horizontal asymptote. So let's go up and look at the degree. It might be easier to look at the first version of this fraction. Okay, so the degree on top, the highest exponent on top is a 1, so the degree is 1. The highest exponent on the bottom is 2, so our degree is 2. So the degree on top is less than the degree on the bottom, so we automatically have the horizontal asymptote, y equals 0. Okay, so let's see what this looks like. Okay, so we have a vertical asymptote at positive 2. Vertical asymptote at positive 2. And we have a horizontal asymptote at 0. Okay, so we know how those should look. Vertical asymptote, horizontal asymptote. Now, we're going to have a hole at negative 2. The holes do not show on your calculator, so this is something that you have to be able to identify and put into the picture. So if you look at your graphing calculator, it gives you a pretty good idea of the picture. If you don't have a graphing calculator, then from here, you would probably have to plot a few points to see what's going on with the graph. So what we're going to have is we're going to have this piece up here, like that. And then down here, there's going to be another L-shaped piece, but we're going to have a hole at -2. It's going to look something like this. Okay, so let's go through and identify all the pieces to our graph. We've got a vertical asymptote at +2. We see that. Vertical asymptote at +2, check. We've got a hole at x equals -2. See our little hole in the graph right there? Again, that will not show in your graphing calculator. You've got to add that in yourself. And then we've got a horizontal asymptote at y equals 0. Check right there. Okay? So the key features of the graph line up, all right? And then we would either fill in with our graphing calculator or by plotting points. Okay, let's try another one now that we've got the idea. All right, let's say that we have all right, let's try this one. R of x is equal to (1 over x squared minus 9). 1 over x squared minus 9. Okay, we know we're going to want 0, so let's just go ahead and factor this from the beginning. The top is not going to factor. The bottom is difference of two squares, so that's going to factor as x plus 3 and x minus 3. Okay, so let's look for our four things. We're going to look for domain, we're going to look for vertical asymptotes, we're going to look for holes, and we're going to look for horizontal asymptote. Okay, so remember the domain, we're looking for zeros in the denominator. From the first factor, we get a 0 at -3, and from the second factor, we get a 0 at +3. So our domain is going to be everything except for -3 and +3. Okay, now those numbers are either going to be vertical asymptotes or holes. One or the other, they can't be both. All right, so remember, vertical asymptotes are the zeros that don't match the numerator. So coming back over to our factors, do either of our factors match the numerator? No, because there's nothing there. So both of them are going to be vertical asymptotes. So we're going to have vertical asymptotes at -3 and +3, and that means that we are not going to have any holes this time. Okay, so no holes this time. Alright, now for horizontal asymptote, we're going to look at the degree. The degree on top, there are no x's, so the degree is 0. And the degree on the bottom is 2. Remember, if the degree on top is less, then we automatically get y equals 0 for our horizontal asymptote. Okay, so let's see if we can fill in the graph now. We've got vertical asymptotes at +3 and -3. So +3 and -3. And we've got a horizontal asymptote at 0. So that's going to look something like that. And then from here, you're either going to look at your graphing calculator or you're going to plot some points to fill this in. So what ends up happening is we have an L-shaped piece up here. That part's familiar to us. We have an L-shaped piece over here. And in the middle, we end up with a shape that kind of looks like a parabola. Sometimes that happens when we're between asymptotes, because when we've got to get close to the asymptotes. So it might look like a parabola in the middle, it might look like x cubed in the middle. Now in the middle, you can cross a horizontal asymptote, because remember, horizontal asymptotes are what happens when x gets very big. So in the middle, you can cross a horizontal asymptote, but you can never, ever, ever cross a vertical asymptote. All right, let's try one more. Let's do r of x is equal to 3x squared plus 1 over x squared. 3x squared plus 1 over x squared. And let's look at our 4 key points. Domain, vertical asymptotes, holes, and horizontal asymptotes. Okay, now before we start, we should try to factor. This one's actually not going to factor. The top is, there's no common factor, and it's not going to factor as a binomial, and the bottom isn't going to factor. So we don't need to do anything there. So the domain this time, we're looking for the denominators equal to 0. We're just going to have 0. So x cannot be 0 for this one. Okay, so vertical asymptotes and holes, we're looking for factors in the denominator that match the numerator. Remember, they have to match exactly. So we'd have to have an x that's by itself for this factor to match. The factor on top is 3x squared plus 1, so that does not match. So our zeros in the denominator do not match the numerator. They're both, well, 0 and 0. They're going to be vertical asymptotes. And that means, again, we do not have any holes. And that's okay, that happens sometimes. Alright, and then the last thing that we're looking for is the horizontal asymptote. Remember, for horizontal asymptote, we look at degree. The degree on top is 2. It's our highest exponent there. And the degree on bottom is also 2. That's our only exponent there. Okay, so the degrees match. Remember, if the degrees match, we're going to look at the leading coefficient. So we're going to look at this number over this number. So our horizontal asymptote is going to be 3 over 1, which is 3. Alright, so let's get this on the graph. So we've got a vertical asymptote at 0. We've got a horizontal asymptote at 3. This. We don't have any holes, and in order to get the graph again, you're going to use your graphing calculator, or you're going to plot some points, and we're going to get a graph that probably not too surprisingly looks like x squared. Okay, so this graph ends up looking like this.